Welcome to the Math Record. This video will cover the second part of the ICTM Regional 2015 Division AA Junior Senior A-Person, which I'll be answering questions 19 and 20. Okay, question 19. Sine of kx equals 4 sine of x cosine squared of x minus sine of x. Determine the value of x for k. So basically, we could just factor out our sine of x first, and we're left with a 4 cosine squared of x minus 1. And then from here, I'm going to split this up as 2 cosine squared of x minus 1, and then plus 2 cosine squared of x. So I just split up my 4 cosine squared of x in half. So the reason I did this is because I know that the double angle for cosine, so cosine of 2x is equal to 2 cosine squared x minus 1, which is this right here. So that means it's sine of x times cosine of 2x plus 2 cosine squared of x. Now I'm gonna distribute this back in, so then there will be sine of x times cosine squared x. Cosine 2x plus sine. Well, I'm gonna put the 2 first, and then sine of x, and then we have our cosine squared of x, which I'm gonna split up as cosine of x times cosine of x. And the reason I did this is that 2 sine of x cosine of x is equal to sine of 2x. That's just a sine double angle. And now you see how this relates to each other. So sine of x times cosine squared of x plus sine of 2x times cosine of x. Well, what does this look like? Well, this is just the trigonometric identity for the sine sum and difference angle, which is basically just adding these two together. This is sine, sine, cosine, cosine, x, and 2x, right? For each one. They just moved it around and then added. So all we had to do is just x plus 2x, that's 3x. So that means 3x is equal to kx. That means our k is equal to 3. So that's our answer for number 19. You just need to recognize that identity. Okay, number 20. K is equal to the infinite summation from 1 to infinity of 3n over n to the power of 7 to the power of n. Determine the exact value of k. So I covered this in one of my videos for my whatever or basically my what is this class, which is the first video which I covered for that series, which is basically the summation of polynomials over exponentials. So basically what it is that instead of rewriting this as one summation, you could rewrite it as two summations. So I'm going to take away the 3 because you're just multiplying a 3. So it's 3 times the summation, and then we have another summation inside. And then we're going to put the exponential, which is 1 over 7 to the power of n. So then n, infinity, and infinity. So it's a double infinite summation. And then our n, x, and then x equals 1. So basically we have this. So we could split this up into something like this. So what can we do with this? Well, we could still always use the regular equation, which is basically the first term over 1 minus the ratio. So the first term is when n is equal to x. So it'll be 1 over 7 to the power of x divided by 1 minus the common ratio, which is 1 to the power of 1. 7 to the power of x is equal to 6 divided by 6 over 7, or basically 1/7 to x times 7/6. So we can substitute that inside here. So we get 3 times the summation from infinity from x equals 1 of 7/6 times 1 to the 7 to the power of x. So we have this. So I'm just going to delete this here because we don't need it anymore, so we don't get really messy. Okay, so we have this. And now this seems way simpler, right? Now you could move the 7 times 6 outside. So 7 times 6 times 3 is 7 over 2 times the summation from x equals 1. This is infinity still. And then 1 over 7 to the power of x. And this is just an infinite geometric series, which is 7 over 2 times 1 over 7, because x equals 1, so 1 over 7 equals 1 minus the common ratio, which is 1/7. So it'll be 7 over 2 times 1/7, and then it's divided by 6 over 7, which is the same thing as multiplied by 7 over 6. So cancel out this with this. So 7 on the top, and then 2 times 6 is 12. So our answer for number 20 is 7/12. And that is your answer for number 20. And that concludes this contest. Thanks for watching, and I'll see you at the next math record.